morning. So today we are going to discuss on the next part of this chapter, that is haloalkanes and haloarenes. As you must have seen on my last video that I have discussed over there about the chemical properties of haloalkanes. Now that was on nucleophilic substitution reaction. We have seen that how SN1 and SN2 reactions differ from each other. Now today we will be discussing the next chemical property of haloalkanes, that is elimination reaction, or in the book it is also known as beta elimination reaction. Now what is elimination reaction? Over here you will be finding, suppose I am giving you one example. Suppose this is an alkyl halide. Now I am reacting this with an ionic compound, that is alcoholic KOH. Now look over here very carefully that between chlorine and the chlorine is attached to this carbon. So as we have said that this carbon to be as the alpha carbon. Now this bonded electrons that are present over here, that are shifted more towards chlorine. Now next to the alpha carbon is the beta carbon. So what will happen? This H will go out, because if KOH is ionic compound, if it breaks, it will give K plus plus OH minus. Now this H will be going out. So what happens? This bond that is present over here between carbon and hydrogen, this bond will be shifting to this carbon atom. So what will happen? This H will be combining with OH and it will be forming H2O. This chlorine will be going out and it will be forming Cl minus. So it will be combining with this K and it will be forming KCl. Now what remains over here? CH3, single bond C. There is a H over here. Now this carbon, as soon as this hydrogen goes out, the bonded electrons are shifted to this carbon. Whereas when the chlorine goes out, it takes away with itself this bonded electrons. So this carbon carries a plus charge. It's a carbocation. It's a 1 degree carbocation. So now, or rather a 3 degree carbocation. So what happens over here, as you can see, this carbon that was having, this beta carbon that was having this bonded electron pair, will be forming a double bond over here with this carbon atom which was having a plus charge. So now it has changed to alkene. That means beta elimination, as the name suggests, from the alpha carbon, as the halogen atom will be moving out, at the same time from the beta carbon a hydrogen has to move out so that it can form a double bond with the alpha carbon. Now over here you should also understand that suppose this is a structure where you can see that this is the alpha carbon. Next to the alpha carbon, this is the beta carbon. Now will over here beta elimination take place? No. Why? Because the beta carbon does not possess any hydrogen along with it. There should be at least one hydrogen to carry out the process of beta elimination, so that the hydrogen can go out and it can form double bond with this carbon. So therefore such type of tertiary structure or tertiary beta carbon structures will never participate in beta elimination reaction. Now let us discuss one more thing over here. Suppose I have given you CH3, CH, again there is CH and H. After this there is CH, over here is H. Now over here comes a halogen. After that there is H, H and H. And I say that react this with alcoholic KOH. So what will happen? This is the alpha carbon, next to this is the beta, this is also beta. So X will be going out along with this bonded electrons. So over here a plus charge will be coming. So according to the beta elimination rule, double bond hydrogen can be removed from here also, from here also. So we will be getting two compounds, CH3, CH2, CH2, CH, double bond, CH, single bond, CH3. This is one. Another one will be CH3, CH2, 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 CH, double bond, CH2. So look over here very carefully. The double bond one time has formed over here, another time the double bond has formed over here. So the question is, both are correct according to the beta elimination rule, but which one will be the major compound and which one would be the minor compound? For that, Seth was a scientist or a chemist who gave a rule that alkene will be a more stable compound, along with which a longer alkyl group chain is being attached. So over here you can see that next to this double bond there is a alkyl group. Over here is also a smaller alkyl group. But over here, as you can see, that after this carbon there is a alkyl group, whereas next to this carbon there is no alkyl group. That means major compound will be this one. It will be yielded 80%, and this would be a minor compound which would be of 20%. This is what Seltz's rule says, that after the double bond, look on both the sides whether there is a longer alkyl group, then that would be the major one, and the carbon, the double bond, where there is no alkyl group or smaller alkyl group, that would be a minor product formed by beta elimination reaction. This is what Seltz's rule states. Now after this, we are going to discuss on reaction with metals. Reaction with metals. As you can see, this is the alkyl halide. When it reacts with magnesium, what happens? It forms RMgX. It is known as Grignard reagent. Grignard was a scientist. After he had done this reaction, and from there the name has been given. Now when Grignard reagent reacts with water, what happens? It forms RH, means water can be split into H plus and OH minus, and magnesium will be forming OH and X. In the book it is written as MgOH X. So alkane is produced when alkyl halide reacts with a metal. Next is, suppose again I am taking two alkyl halides. This is Wurtz's reaction. Very, very important for your exam. Wurtz's reaction states that when two alkyl halides are reacting with a metal, that is sodium, in the presence of dry ether, what it will be giving? It will be giving R single bond R plus 2NaX. So over here it is also a alkane. So see, two alkyl halide molecules, RX and RX. What happens? This halogen goes out and combines with the two sodium atoms, and this alkyl group among themselves, they form a bond and produces a alkane. This is the concept of Wurtz's reaction. So metals always give from alkyl halide alkanes. Now next topic will be, we are going to discuss on, that is on chemical properties of haloarenes. Now before I start with haloarenes, see, in my last class I said that a nucleophilic reaction, how it proceeds. Suppose here is a double bond, here is a double bond, here is a double bond, and chlorine is present over here. So what will happen? By the help of the resonance, this bond comes over here, and as soon as it comes over here, what will happen? Over here there will be a plus charge, chlorine is present. Now when this double bond, these electrons come over here, this will be going over here. So it will be next, after this, what will happen? This bonded electrons will be coming over here and it will be going over here. So it will be minus charge, double bond, and Cl, a plus charge. And at the end, again it will be returning back to the same thing, that is double bond, and Cl will be like this. So now look over here. Our nucleophile will always be getting attached to this position because nucleophiles carry a minus charge and they have a tendency to get attached to the positive charge. Why nucleophile? Because nucleus loving, and we all know that nucleus are positively charged and nucleophiles are having negative charge, so they always have a tendency or affinity towards the positive charge. So always the nucleophiles will be getting to attached to this position. They will never be getting attached to the ortho or to the para position, because everywhere you can see minus over here is also minus, over here is also minus. So electrophiles will be getting attached to the ortho and para positions, but nucleophiles will always be getting attached to this position where the chlorine is attached and where a plus charge is being given. Now let us take some examples and see. The number one is, this is a chlorobenzene. It reacts with NaOH. It's an ionic compound, it's a base. At 623 Kelvin and at 300 atmosphere, what you will be seeing, that Na will be coming, Cl will be coming out, and in its place OH comes. So always remember, electron withdrawing groups occupy or are present, if present in ortho and para position, more active will be the compounds. Over here, is there any electron withdrawing group present? No. So what happens actually, see, now over here only one Cl was present. Now if I bring a Cl over here and a NO2 over here, now if I react this with NaOH, you will be finding that the temperature decreases. It becomes 443 Kelvin. Why? Because due to the presence of NO2 group, which is an electron withdrawing group, what will happen? The temperature decreases and chlorine will be removed and OH comes over here and NO2 remains as it is. Now after this, if I again bring another NO2 gets attached to the ortho position and para position, then you will be finding that the temperature again decreases, because it's now getting much easier for the Cl to get displaced by OH, because the electron withdrawing groups, that is NO2 group, since two NO2 groups are present in the ortho and para position, so it will be becoming more active at a less temperature. So OH comes over here, NO2 remains as it is. Now after this, if I again react this chlorobenzene, and if this time NO2 is present in both the ortho positions and as well as in the para position, what you will be seeing, that the temperature decreases to the least. By hitting it at a very low temperature, by warming it, you will be finding that Cl displaces itself and in its place OH comes and NO2 group remains as it is. So this is what, or this is how, due to the presence of the electron withdrawing group, more the number of electron withdrawing group, that compound becomes easily active. These are all given in the NCERT. Now next topic is, look very carefully that always the electrophiles are getting attached to this position, because this is having a plus charge. Because as soon as chlorine goes out, what happens? This double bond shifts over here. This double bond shifts over here. So basically a plus charge comes over here, as I have shown it in the resonance. So in the plus charge, always who will be coming? Because OH minus and this is plus. So this will be occupying this one and OH will be occupying this position. This is what nucleophilic reactions are all about. Now we will be discussing on the next topic, that is on electrophilic substitution reaction. Electrophilic substitution reaction. Over here you can see that when chlorobenzene reacts with chlorine, or chlorination is being done under the presence of FeCl3, anhydrous FeCl3, it's a Lewis acid. What happens, as I stated you, that always the electrophiles will be occupying the ortho and the para position. So two products will be formed. One time the chlorine will be getting attached because it's a homolytic cleavage. Another time the another chlorine atom will be getting occupied at the ortho position. Since this is a symmetrical one, so this would be a major product and this one would be a minor product. Now from here, if I again react chlorobenzene with, under the presence of concentrated HNO3 and concentrated H2SO4, what it will happen? It will be giving you Cl, and one time again the NO2 will be coming at the para position, and another one time the NO2 will be coming in the ortho position. So again this would be a major product since it's symmetrical. Now if I react this chlorobenzene with concentrated H2SO4, means sulfonation, this one was nitration, this was nitration, this is very, very important. Now if I react with sulfonation, so H2SO4 will be breaking into H plus HSO3 minus. So what it will be happening, it will be forming Cl, one time it will be forming HSO3, another time it will be forming Cl SO3H. Sorry, this would be SO3H. So again, as you can see, each time the same phenomena, para and ortho. Para will be the major one. So this was what electrophilic substitution was about, ortho and para position, and para position compounds are much more major because they have a symmetrical structure, whereas ortho they do not have. Now like this, there are some important reactions like Friedel-Crafts reaction. What is Friedel-Crafts reaction? Friedel-Crafts alkylation. This is a very important reaction. See what happens over here when an alkyl group is getting attached to the benzene ring. Chlorobenzene, and I am reacting this with methyl chloride in the presence of anhydrous aluminium chloride. So what will happen? This CH3 will be again be getting occupied. One time Cl is occupied, CH3 is occupied over here. Another time CH3 will be getting occupied in the ortho position. So the same phenomena, it will be a major one, this will be a minor one, because this is again the electrophilic substitution reaction, because plus charge comes over here in the, as soon as the chlorine goes out. This is minus and this is plus, because the bonded electrons are shifted more towards this, so chlorine goes out. So these are the few reactions that are in your syllabus. It's very, very important. Electrophiles will always be occupying the ortho and para positions, and nucleophiles will always be occupying the topmost position where the plus charge comes as soon as a group leaves. Now few reactions are there like Wurtz fatigue reaction. Wurtz fatigue reaction, this is the reaction with metals. What happens when chlorobenzene, I am reacting chlorobenzene with alkyl halide and with a sodium metal, what happens in the presence of dry ether? You will be finding that the alkyl group gets attached to the ortho position and it becomes 2NaX. And chlorine remains as it is. So over here, this is a aromatic halide and this is a aliphatic halide. So both when reacted together, what it gives? The alkyl group comes to the ortho position, chlorine remains as it is, and it becomes 2NaX. And the last one is Fittig reaction. You will be finding over here chlorobenzene when reacts with two sodium atoms in the presence of dry ether. Now this reaction is again very important. It will be forming a biphenyl structure. This is what, and this if you balance it, it will be 2-chlorobenzene. So two benzene molecules are combining and it forms 2NaCl. It's a biphenyl structure. So this is what actually is all about in your syllabus. These are the two metallic reactions. Over here aromatic and aliphatic comes, and over there as you can see in the electrophile and nucleophile, as I stated you. So this is what haloalkanes is all about. One more important thing, the last thing in the NCERT will be finding about the chloroform. One question comes why chloroform is stored in dark colored bottles. So write down this reaction, CHCl3 plus O2. In the presence of light, it changes to phosgene. It's a chemical weapon, or rather it's used in chemical warfare, and that's why always chloroform, it gets oxidized to phosgene. So always chloroform is stored in dark colored bottles so that it does not get oxidized easily. So this is what haloalkane and haloarenes are all about. In my next video, I will be discussing few questions of this chapter from NCERT. Go through the topic that I have taught you today. If you find any difficulty, you can ask it to me in Zoom app from 6 p.m. every day. And if you like my channel, subscribe to my YouTube channel.